Hi, this video is about putting everything together. So we've looked at different things in Greenfoot, we looked at Java, stuff like that. So now it's about time we try to create a small, maybe not game, but let's make some more intelligent objects and get started on creating games. So I'll just start out by creating a new scenario. I'll choose Java scenario. Stride is just another programming language that is supported by Greenfoot. So Java scenario, and this one it says lunar copy. I'll call this something like test. Bad name, I already have that. Let's call it something like fun. So now I have my new Greenfoot project. So what I'd like to create for this example is I'd like to create a mouse, and I'd like to create some food, and I want this mouse to be intelligent. So we're looking for creating a class that will have some intelligent behavior, so that kind of like an AI player. Sounds complicated, but in this case not. So I want a mouse that will look for food, and if it can see food anywhere, it will move towards it, and when it finds the food, it will eat it. That's just it. So let's just try. So I think first off, when we're talking about object-oriented programming, the first thing we will do is we kind of think, what do we need if we want a mouse that looks for food? It's quite obvious that we need to have an actor that is a mouse. So let's go for that first. So I'll right-click actor and say new subclass. And I will write mouse, and remember to have M capitalized because it's a class. We go to animals, and I know there's a mouse in here somewhere. There it is. Mouse, click OK. So now I already created a mouse class. I can look at the code behind it. See, it's kind of empty. And I can right click the mouse and create multiple mice if I want to. And right now they don't have any behavior, so they're kind of stupid. So let's create some food as well. So I also right click actor, new subclass. I won't call it food. Let's look into food. What do we have? French fries. We know mice, they love French fries. So I'll just I'll call the class French fries, and I capitalize the first letter because it's a class, and also the second letter because it's two words here. Because French fries is two words, not one. So the second word, we cannot use spaces here. So instead we just capitalize each word. And then we click OK. So now we can create a mouse, and we can create some French fries here. Nice. So right now the behavior for the French fries is just to sit there. The behavior for the mouse is just to sit there. And that's of course because we defined the behavior in the class. So if I go into the French fries class, I can see it does absolutely nothing. So first off, let me just think, what do I want the mouse to do? I think what I wanted to do is I wanted to kind of look around, just like think about, see if we can find some food. And we all know that mice have very good, they can smell food in a long distance. So this in this game, anywhere on the screen that we have food, we can kind of smell it and go towards it. So we kind of want to emulate that. So let's go here. So first off, I'm thinking we want to sniff for food somehow. Want to use nose for finding food. And the second thing I'm thinking is that we should turn towards our food, and then move towards. And then the last thing we should do is, if we find food, eat it, right? So these are kind of 4 steps I'm thinking for this AI thing. And I'm writing as comments now because then I can solve the problems one at a time. Sometimes in programming, if you try to overthink it and you want to do everything at once, it gets quite complicated. So if I'm kind of thinking, I need the mouse to find the food, I need the mouse to move, I need everything, it gets kind of complicated very fast. So let's look at the problems we have at hand. So first off, finding the food, turn towards the food, move towards the food. So moving is quite easy. So let's try solving that first. We cannot move towards, if we turn towards the food, we automatically move towards the food. So I just need to move, and if we look into the actor within the Greenfoot library here, we can see somewhere there is actually something just called move, like that. So quite easy. So we'll just say move and then 4. So we'll move 4 cells, and we can just, oh, I'm looking, this is the French fries. I did so I can see here it's the I actually wanted to move the mouse and not the French fries. Otherwise the French fries will eat the mouse. That's kind of a weird game. That could be fun too, but not what I want in this case. So let's open up the mouse instead. I'll just move it here. So that's it. So now I actually created the first part of my AI thing for the mouse. If I put the mouse here now, it can actually run. Right? I can move it and it moves in the direction that it points. So first off, we can see how can we turn towards something. Before we turn towards something, we need to find it. We need to know if there's actually any food here. So first off, I would like to make a method that finds food by using the nose. So we could call this method something like sniff for food. Again, I'm using capitalized letters, not for the first one because this is not a class, this is a method that I want to create. And I'll just use parentheses to say that this is a method I'm calling from here. And what I want back from this method, and I haven't made it yet, so don't get confused on that. I'll make it later. But sniff a food, I want actually to have some French fries. Let's call it FF. So I can use the sniff a food method to get French fries that are anywhere near my small mouse here. So now of course it creates an error saying there's nothing like sniff for food. What are you thinking? So I'm going to create that method. So first off, we want the modifier, and the modifier in this case is just private. We don't want anyone outside to use this method, so it's just going to be for the mouse class only. The next thing we want is we want the return type. So we want to say, what does sniff for food actually return? We want it to return French fries because otherwise we can't save whatever we find with our nose here. And of course the rest of it, the name of the method and the parentheses to signify we are talking about a method, and then I use the curly brackets to say this is the code for this method. Okay, so modifier, return whatever it needs to return, and then the name and the parentheses to signify that this is a method and there is no parameters for this method. We don't need that, it needs to find it. So the next thing is, how would we want, if we want to find, just to make it work, because right now we have an error, this method needs to return something. It needs to return French fries. So I'll just say return, and then I'll just type null. And null just means return nothing, return empty. So the French fries will be kind of just an empty. It won't really be an object. It will just be a special kind of object that's called null, which is not which is the opposite of an object. It's nothing. So we return nothing for this, but it makes it work for now, and we'll use that later. So now we fixed everything. So if we want to find food, we need to figure out how can the mouse actually access the French fries. So let's say I have a mouse here and I have some French fries here. How can the mouse find out that there's French fries here? So let's look into let's try to look into the Greenfoot library and figure out, can we actually find something, and there is a method for doing that, because this is often something we want to do in games, to look for something else. So if I open up the browser and go to Greenfoot, the Greenfoot documentation, and look at the actor, I can find that in here somewhere we should be able to see what's on the world. So one of the things you can see, there's something called get neighbors. So we can look at the diagonal. So this is kind of a distance and diagonal. There's something called get objects in range and get one intersecting object. So, but what I would really want to do is, I want this get objects in range, because I can just define a radius and a class. So I can, for example, say I want everything in the radius of 5 fields, and it should be the class of French fries. So any French fry within that radius would be put into a list that I would get back. So get objects in range is interesting here. So we go back to the game, and we need to do that then. So what I'm going to say, I have a list of French fries. This is what I get back, and I'll call it ff list, and I need to get, so I'll say objects in range, and I'll need to specify the range first. If I do 600, which is it should find anything, because it's 600 times 400 right now, so that should be enough. And I also need to specify the class, so I write French fries here, right? And it's kind of special, I need to write .class here for this to work, okay? So for now this is quite complicated, but this is the way we can get a list of all the French fries in the entire world. So these will go into a list. Unfortunately, list is not part of Greenfoot. It's part of Java's basic library. So we need to import the list before we can use it. And to do that, you have to know where list is in Java. So, but we can actually see there's a small cheat code here. It says it's in the Java package and the util package under Java, and then list. So if I just import that, either I can write it down here, like I could write java.util.list like that, or I can just import it, which I think it is easier to read. So I'll just say import java util list. So this I need to do for that to work. So now I have my list here. I can get all the objects in range, and it will automatically have a list of French fries. So I know by chance that if I say return and then ff list dot get 0, this will give me the first French fries that it finds. So wherever that French fry is, it will give me that. So I'll just return whatever first it finds. So there is a small problem. So let's say there are no French fries, we just have the mouse here. Let's just exemplify that. So let's say we just have the mouse like that, and there are actually no French fries here. So if we kind of run this, we get errors, and that is because if we try to get an element that's not there, we get an error. So first off, we need to check to see if the list is empty. We need to do that. So we're going to say if, and we'll look more into these things like if and else and stuff later, but for now we can write if, and we can do ff list dot is empty. So if the list, do the curly brackets, if the list of French fries is actually empty, we can't do the get thing because we can't get something that's not there. So in that case, I will return null like that, just like we did before. So if there is nothing in the list, we return an empty object. That way anyone sniffing for food will know if it doesn't find any food, I just get like nothing back. So the mouse can't actually smell anything in this case. So if it's not empty, we can just say else. This means if it's not empty, because up here it says if it's empty, do this, otherwise do this stuff in here. So if it's not empty, I will say just return the first element. We only want the first one. Doesn't matter, mouse will just go for the closest any one French fry that it can find. So now we change the behavior of the mouse to actually being able to find French fries. So that means that our sniffer food will give us one package of French fries. So now we have that, it's called FF. So this was the sniffer food thing, but what we need to do as well is we also need to use this food for something. We want to turn towards the food. So we want to turn towards FF. So the next thing I'm going to do is I'm going to check like this. I'm going to say that if this FF is not equal to null, and that means, this means that if FF is not equals, the exclamation means not equals, means equals, so it's not equals. So if FF is not null, then we want to do something, because if it's null, we can't go anywhere. We don't want to do anything. So I'm actually also thinking we'll only move if there's actually something to move towards. So that means the mouse will stand still. If it can't find any food, it will just stop. And we need to turn it towards the food. So we're going to say it's called turn towards. I can remember that. You can also go look it up here. If we go down under T, we can see turn towards an X and Y value. So we need the X and Y value from the French fry. So let's say ff.get X and ff.get Y. And these are methods on actor, because French fry is an actor. We can call these methods. Let's go. Actor should be here. Yes. Get X, get Y. And of course, right now we probably can't remember all of this stuff, but you have to work with it and look at examples, and you'll get it eventually. So if it's not null, if there is actually French fries to look for, we turn towards them and then we move. So that's it. So now we should actually be able to go towards the food. We can't eat it yet, but we can go towards it. So let's try to make a new mouse and some French fries. And then, wow. So the mouse will just go there and then kind of wiggle around, because it will go past and then go back and go past, because right now it can't eat it, so it will just be there forever. So it will just try to get into these French fries, but it cannot eat. I don't know, maybe glued its mouth together or something. So we need to make it able to actually eat the French fries. So this is the next part. So now we can move it towards, and I can show you it will work from anywhere basically. We can move the mouse in any direction. So we kind of created an intelligent mouse here that actually knows about how to find the French fries. So it's really nice. Okay, so next thing is to eat. So let's make a method for eating the actual food. So I'll just make a method called eat food, and this time I won't return anything. It's just a small helper to make it easier to read this. So I haven't created that, so I'll do that. Again, I'm going to make it private method, only available to this class. This time I won't be returning anything. I'm not using this like up here where I'm saying French fries equals the whatever comes back from this method here. So I don't need anything here. So I'll type void, which you can kind of say it's the same as null, right? It's not, but you return nothing here, so you can't return anything here. It's just a method that you run, and it's called eat food, and we need the curly brackets and everything. Nice. So now we are ready for the eat food method. So what are we going to do here? So if we want to eat food, I'm just thinking, let's just make it disappear from the world. So if we eat the food, we should be able to remove it from the world. So if I say get world, I get the world. That is the my world thing here. And if I say get world, I can say remove object. And again, you can find this in the documentation. If I go here, go to world, should be something called remove object. Yes, and we can put any actor here. So because French fries is an actor, we should be able to remove that. Oh, so now we have a problem because I don't know, because ff is defined in the act method, I can't use it down here. I need to remove ff, right? But I can't do it down here because eat food doesn't know about ff, because something like ff is called a local variable. We talked about this, and this is only available within these curly brackets where it's defined. So we need to kind of move it into the eat food here. So we put it as a parameter like that. Sorry. So put it in here as a parameter, and we need to put it here. So when we define a parameter, we can't just write like ff. We need to tell it which type of parameter it is, and the type here is French fries. And I won't call it ff just to show you that I can call it anything else. So I'll call it French fries like that. And again, I'm not using capital start letter because this is the name of the parameter. It's not the class, and here it's the class. So it's a big difference here. And I do like this. So this means that it will remove the object coming from the outside. So I defined anything that goes into eat food method will then be sent here to be removed. And up here, because act actually knows about ff, I can take ff, send it to eat food, and eat food can remove it from the world. So that should actually work. So let's create a mouse, create some French fries. Let's make 2 this time, and then go a bit slow. Wow, that wasn't good. Did you see that? Try to do it again. French fries, and a mouse. Act, then it eats 1, then it eats the second one. Oops. So the problem is now it actually eats the food, but it doesn't need to be close to the food to eat it. It can eat it by distance. So this is a very cool mouse, I think. It can actually eat food from a distance, doesn't even need to move. So I think we should make it a bit more realistic. So let's think of this, in order to eat the food, to actually remove it from the world, first I want to check if the food that it's actually looking for, is it actually touching it? So if we go back to the actor, there's something called intersects somewhere. Probably that's here it is. So we can check to see if an object intersects with another given object. So if the mouse intersects with the food it's looking for. So first, before we remove the object, we say if intersects with French fries. So if we intersect with the French fries we're looking for, then we remove it. So only when we touch the French fries we will eat them. So eat food, we'll only eat it if you're close enough to do that. And as I said before, we could move this code, this part here, and we could take all of this and put it up here, but this will just make a giant act method, and this is easy to read if you look at it. For example, now I have a comment here saying sniff for food, but if I remove that, you can actually kind of read it just by looking at it, like sniff for food, and then I get French fries. Okay, I kind of know what's going on. So I check to see if the French fries is not null. I turn towards the coordinates of the French fries. Pretty easy to read, right? And then I move, and then I try to eat the food. That's easy to read. So this is one way, one good way of putting it into methods by itself. But of course, we could just put it directly here. So let's try it out. So now it shouldn't be able to do this telekinetic, I don't know what that's called, when you can eat at a distance. So let's try again and see. Now it's moving. I don't know. I think it set its mind on this one, although this is closer. So it's not that intelligent, but it can smell it. So we'll let the mouse eat that, and immediately it goes to the next one and the next one. So no matter how many, whoa, some error. Let's fix that afterwards. But no matter how many French fries we put on the screen, the mouse will find them. Okay, so now we had an error. This is something you will have a lot of, so don't be scared. It says something like index out of bounds exception, which means we've broken something. But we can see it says it's mouse sniff for food line 27, the first one. Okay, we go here. It says it needs to eat the food. So eat food, if ff comes back as null, if it doesn't find any food, so when all the food is gone, eat food will send null down here and we'll try to remove null from the world. And we can't do that. So we should only do this, eat the food, if actually we found some food. So I'll just move this part into here, because then we will only eat the food if the food is not null. So it makes it even easier to read. If we find some French fries, we start turning towards them and moving and then eating. Right? So even without these comments, it's pretty easy to read now. Maybe this one as well. So first off, sniff for food. If there is food, we turn towards the food, we move, and we eat it. Very easy to read. And now I think we also fixed this error here. So let's try to go new mouse, French fries, French fries, French fries. So we put some here and we run, and it eats all the food and no errors. This is the old one. We can clear, and I can show you again just to show that it's not, if I'm fast enough. Ooh, like that. So that's it. So this is it. So now the mouse can actually eat the food. So again, we are back to the very powerful thing of this object-oriented programming, that the behavior is copied. So actually now, let me show you something really cool. So actually now we have it working, and I kind of did it one thing at a time. So now this behavior that the mouse has, like I showed you with this here, like all of the, because we use kind of the same mold, or we use the same recipe for everything. The cool thing is we also have the same behavior. So for example, if this was a tower that could throw arrows or something like that, that that would actually work for all the towers if this was something that would be put into this. So this is the same thing in our mouse now. It has its own life. And the cool thing about that is that if I do it like this and then run, then the mouse will try to get the french fries. But an even cooler thing is that if I pause and create two mice and multiple french fries, then they will all try to go for the same food. Let's see. So we can have all the french fries in the world and all the mice in the world, and the mice will actually act like mice. They'll try to find food. This is what they do, and if there's no food, they will just stand still. So I think this is a very, very important and cool feature with this kind of programming, that we can have objects that can just live on their own and be totally autonomic, um, and work on their own. And once we created the mice, it's very easy. We can, and we could also, you'll learn later that you could, for example, have many different kinds of food, like French fries and nuts and things like that, and they would go for that. You could also have foods that they would smell and go to, and then maybe the food will have something like, do they like this or not? Maybe there's, if it's poison, they won't eat it or something like that. So there's a lot of stuff we can do with this, and of course we can do backgrounds and all of this stuff. But this is basically just to understand the workings. If you don't understand things like if right now, or don't understand this if else part and the list part, this is normal. I just need to do some code for this to actually work. But what I want you to understand here is, more importantly, that we have different classes, and these classes can be instantiated and have their entire own lives that you can define and copy it, as many as you like, and they will just do whatever you want them to do. So that's it. Thank you for watching.